Okay, Rahul, let's proceed ahead with your mock for thermodynamics for Bhabha Atomic Research Center, right?
Yes, sir.
Okay, so Rahul, can you tell me something about thermodynamic processes?
Yes, sir. Thermodynamic process, sir, means if we move from one state to another state, we go through a process. There are different types of processes: constant pressure process, constant volume process, constant temperature process, adiabatic process, and polytropic process. So these are the different types of processes.
What is quasi-static process?
Sir, quasi-static is a very slow process, sir.
Okay, on the TS diagram, plot two processes. One is isothermal and
Yes, sir.
another constant temperature process from state 1. Draw these two diagrams on TS diagram. Draw these two processes on TS diagram.
So isothermal and constant temperature.
Yes, isothermal process and constant temperature process.
Sir, I guess both will be same, right?
Are you sure both are same? One is reversible process, another is real process. Isothermal is a
Yes,
reversible
sir.
process.
Yes, yes, sir. Yes, sir. I got it. So it will be like this. One will be solid and other will be dotted.
Both should start from the same point. 1. Initial state is same for both the processes.
Sir, in that case, one will be solid and other will be dotted.
But will we both be overlapping?
Yes, sir. Because initial states are same.
So suppose this is a heat provided, heat supplied to both is same.
Yes, yes, sir.
What is the end point in both the cases?
I see. Entropy in this case. Sir, in case of a constant temperature process, sir, the temperature will increase because the process is real. So
Tell me again.
it is not. Sir, in case of constant temperature process, the temperature, I guess, since it's a real process, the temperature will increase as we supply heat.
No, but it is a constant temperature process. How temperature will increase? I'll give you an example. If you are vaporizing a liquid, you are heating and it is undergoing
Yes,
the
sir.
boiling process or vaporization process, right?
Yes,
So
sir.
constant temperature heating.
Okay, sir.
So constant temperature heating is the process which is the real process I'm talking about. Another is isothermal process I've given you. The starting point for both is same. Now
Sir, endpoint will also.
endpoint you have to tell me. Now I supplied Q heat. Both the cases I supplied same heat.
Yes, I got it.
You have to tell me now if starting point is same, where will the end point for both?
Sir, endpoint for constant temperature process will be means somewhat longer than the isothermal process because the entropy generation in that case will be more.
If entropy generation is there, don't you think entropy change will be less? What do you think? How do you calculate entropy generation? I agree there will be entropy generation in a real process. That is true. Which equation do you use to calculate entropy generation? Can you write second law of thermodynamics?
Yes, sir.
Yes. Please write second law of thermodynamics for a process.
So it will be.
Okay, you have done integration. It is not for process. Process is dq by t only. But anyhow, now tell me dq is same in both the cases.
Yes, sir.
Right?
Yes, sir.
Now tell me ds. How will be ds calculated? In one case, dq is same. In one case, you are getting ds generation also.
Sir, the entropy change will be more for the case of constant temperature process.
Okay. Why you said that?
Sir, since we are supplying heat, means in both the cases we are supplying it, but whereas in case of isothermal process, the entropy generation will not be there.
Yes.
Since
So
it's
now can you draw the diagrams both? In the same diagram, please draw both.
so it will be like this. This will be for constant temperature, and this will be for isothermal.
Now the rectangle which you have made under the real process, you made a small rectangle, right?
Yes, sir.
What is the area of this rectangle giving you?
Sir, heat that we have supplied.
Are you sure? How shall you calculate irreversibility from this? Length of this rectangle is ds generation, right?
Yes, a change in entropy.
Change in entropy or entropy generation? Length of this small rectangle.
So change in entropy. Yes, a change in entropy.
So real process and reversible processes. So 1 to 2, as you can see in the diagram, 1 to 2 is a
Yes,
reversible process, right?
yes, sir.
2 to
Reversible
3 is
process.
1 to 3 is a real process, right?
Yes, a real process. Yes, sir.
So 2 to 3 is the entropy generation. Can I say that?
Yes, sir. Yes, sir.
So 1 to 2 is entropy change as you have calculated.
Yes, sir.
So entropy change, total entropy change is 1 to 3 in real process.
In real process. Yes, sir.
So that consists of dq by t part and ds generation, right?
Yes, sir.
Can we say like this?
Yes, sir.
My question is, what is this area? Can you see this?
So that is representing entropy generation, sir.
But
For
not the area.
real process.
Entropy generation is a length.
Yes, sir. Entropy generation.
What is the area?
So it will represent heat only. Yes.
Okay, calculate the irreversibility. How shall you calculate irreversibility in this?
Sir, for real process.
How shall you calculate irreversibility in this?
Sir, it will be T naught into ds, surrounding temperature into change in entropy.
As to Dola equation you have done?
Yes, sir.
That is T naught into ds generation.
Yes, sir.
How shall you calculate irreversibility in this now?
Concentration.
Just draw the line of T naught. Where is T naught here?
So T naught will be somewhat lower than the actual line.
Yes, draw the line T naught.
So this,
Yes, now area under T naught ds. Can you see the small rectangle now?
yes, sir.
This.
Yes, sir.
Now T naught into ds generation is the irreversibility.
Yes, sir.
Can you see this?
Yes, yes, sir.
T naught into ds generation.
Yes, sir.
That is the irreversibility. Tell me
Yes,
something
sir.
about available energy, unavailable energy.
Sir, available energy is the maximum amount of work that we can obtain by bringing the system to that state.
Okay, and what is unavailable energy?
Um, Sir, unavailable energy is the the means the maximum irreversibility generated in a process.
What is the relation between irreversibility and available energy?
Sir, irreversibility is basically equals to maximum work minus actual work that we get. So here the maximum work is representing the available energy.
But what is the relation between entropy generation and available energy?
Sir, entropy generation, so it will be equals to T naught into ds according to Gauss-Schrodel theorem. Gives irreversibility, rate of irreversibility.
So can you calculate available energy in a glass of water?
Available energy in a glass of water. Yes, sir.
How?
Yes, sir. Sir, if the glass of water means is having the temperature same as the surrounding temperature, in that case, the internal energies will be equal, and we'll calculate the entropy change, sir.
Do you need any information from my side to calculate that? What is the available energy at dead state?
So zero, sir. Sir, in that case, for the glass of water, it will be zero, sir. Because the
Only if it
temperature
is a
meant.
dead state. So
Yes,
is
it
the
is.
glass a dead state?
Yes, sir. Since the temperature is same as surrounding temperature.
But how do you define the dead state?
Sir, when the system is in mechanical and chemical and thermal equilibrium with the surrounding.
Okay, what else?
So basically, it is in thermodynamic equilibrium with the surrounding. It should be in
So I give
thermodynamic
you cold
equilibrium.
drink, a bottle of cold drink,
Yes,
chilled
sir.
water of cold drink.
Yes, sir. Yes, sir.
Calculate the available energy in it.
Uh, So in this case, the available energy will be Q. So it will be Q in bracket 1 minus T by T infinity. In this case, sir, the cooling is at a lower temperature than surroundings, so the heat will flow, and the temperature of the cooling will increase. The heat will be calculated from the equation MC delta T, temperature of the surrounding minus temperature of the cooling, and then we will apply this equation. Available energy equals to Q. So it is giving the maximum amount of work that we can extract.
You have calculated unavailable energy first.
So we can calculate from this.
What will the entropy change of system in this?
Sir, it will be MC ln T by T infinity.
What is T and what is T?
MC. Sir, T initial will be it will be T final by T initial. So MC ln T infinity by T. In that case, the entropy comes out to be positive. So entropy of the cold drink will increase, sir.
Yes. So delta S we will take of entropy. So unavailable energy will be?
So it will be Q into T by T infinity. 1 second, sir. Sir, unavailable energy will be T naught into ds, where ds is change in entropy for both system and surrounding. For surrounding, it will be minus Q by T infinity, and for system, it will be MC ln T infinity by T. When we multiply it by T surrounding, temperature of surrounding, we will get unavailable energy.
Okay. Rahul, let me give you the feedback now. Rahul, you need to revise the concept of available energy, unavailable energy, and irreversibility.
Yes, sir.
Irreversibility is T naught into delta S generation.
Yes, sir.
Delta S generation means delta S inverse, which further means delta S of system plus delta S of surrounding.
Surrounding.
Right? So for calculating irreversibility, all you need to do is you need to know the ambient temperature T naught and entropy change of system plus surrounding. Now it may be possible that system is finite heat capacity body and surrounding is infinite heat capacity body. Now for cold drink or hot cup of tea,
Yes, sir.
how do you calculate available energies? First you need to calculate unavailable energy.
Yes, sir.
Unavailable energy is P naught into delta S associated with heat supplied to system.
Yes,
So in
sir.
this case, that is MC log of T2 by T1.
Yes, sir.
MC of the bottle, chilled water, it must be having mass, it must be having heat capacity, right?
Yes, sir.
And log of T2 by T1. T2 is the final temperature, which will be of room, 30 degree
Yes, sir.
centigrade, 273
Yes,
plus 30 degree,
Yes, sir.
303 Kelvin. And
Yes,
T1
sir.
is, let us say, 5 degree centigrade, chilled.
Yes, sir.
5 degree पे है तो 273 plus 5, 278.
Yes, sir.
Delta S of the cold drink is increased.
Yes, sir.
T naught is 303. So what is unavailable energy? 303 log of M plus 303 into MC log of 303 over 278.
Yes, sir.
Unavailable energy. What is available energy? Q minus unavailable energy.
Yes,
So what
sir.
is Q? Q is
Sir, Q
MC,
the
delta T.
delta T, yes, sir.
Delta T is how much? 5 degree centigrade to 30 degree. 25.
Yes, sir.
MC, you know, delta T is 25. Q aa gaya, unavailable energy is there. Then you can calculate the available energy also. Just marathon videos, please watch.
Yes, sir.
Marathon videos you have to watch again and again.
Yes, sir.
Thermodynamics, fluid mechanics, strength of material. Watch it as many times as possible.
Yes, sir.
And that will put you, actually there, you know what happens is, quick response in the thinking direction is required.
Yes, sir.
This particular thing is directly from marathon
Yes, sir.
video. So if you've done marathon very nicely, it will put you in a very good position.
Yes, sir.
Done?
Yes, sir.
Okay, Sai.